Hello, ladies and gentlemen, and welcome back to question number 15 on the grade 11 Fermat paper from the year 2002. In a sequence of positive numbers, each term after the first two terms is the sum of all previous terms. If the first term is A, and the second term is 2, and the sixth term is 56, then the value of A is... Okay, so we're creating a sequence of numbers, and it's got what's known as a recursive definition. The value of the next term depends on some or all of the previous terms. The best example of this is the Fibonacci sequence, which hopefully many of you have seen before. Now this one isn't the Fibonacci sequence, but they're both recursive, that's why I bring it up. So, we know the second term is 2, and we know the sixth term is 56. Now, when they do questions like this, when they do a sequence problem like this, you sort of have to judge for yourself, but it all depends on what terms you're given. So if I was given, say, the first term is A, the second term is 2, and if I were given something like the 10th term, or more likely the 20th term, something like that, I would want to take a step back and analyze how this sequence is developing and see if I can come up with an arbitrary formula for any term in my sequence. Okay, that's what I would do. They get these every once in a while with questions that, here's a sequence and then, the year's 2002, so what's the 2002nd term in this sequence? That's really common, and there you want to sort of develop a technique, a general way of writing out each term. So that you can just say, okay, I want 2002, I'll plug in n equals 2002 into whatever formula I've got, and then we're done. But with something like asking about the fifth and the sixth term or the fourth term, something like this, it's often a lot quicker, I find, to just start writing out the terms of the sequence without care for, okay, what's the third term, specifically in terms of that number 3 for the third term. And that's what we're going to do here. So first term is A, second term is 2. Well, what's the next term, the third term? It's the sum of all previous terms, so it's going to be A plus 2. What's the sum of the fourth one? Sum of those 3. Because we're only going up to the sixth term, we'll get an equation, something or other in A is equal to 56, and we'll be able to solve it. And so we won't need to do anything fancy with figuring out general terms. We should hopefully, after a little while, just get this should be the sixth term, but I know the sixth term is 56. Okay? So that's the idea here. But as I say, if it were something larger than the sixth term, especially if it were something like the 1000th term, then we certainly would want to figure out a general term for the sequence. But that's just our first term here is A. The second term is going to be 2. Our third term, it's the sum of everything that came before it. That was the rule. Our fourth term is going to be the sum of everything that came before it. So A plus 2 plus A plus 2. Now I'm going to take the time to simplify that. I've got 2 A's, and 2 plus 2 is 4. So the fifth term, that's going to be the sum of everything that came before it. So A plus 2, that's the second term, plus the third term, and plus our brand new fourth term. Okay, and once again, we're going to take some time and simplify it. And we got 4 A's, A, and 2A. So that's 4 A's, and we have 8 there. And if you notice, starting with the third term, we double our sequence each time. And you can work that out if you wanted to. You could get a general term. So I guess the n plus second, or n plus 2th term is going to be 2 to the n times A plus 2. If you wanted that. If that was the sort of thing you're looking for. If you want to approach the problem that way. But as you can see, we don't need to. We can just add up everything that came before it. And we're already at the sixth term. So we just need to simplify this. See, we have 8 A's, and 2 plus 2 is 4, plus 4 is 8, plus 8 is 16. And we know that that's going to be equal to, we'll just leave this up as an aside. So 56 we know is going to be 8a plus 16. Well, let's solve for a. So bring the 16 over to the other side. But 56 minus 16, that's just going to be 40. 40 is equal to 8a. Well, 40 divided by 8 had better be equal to a. So 5 is going to be equal to a. That's our answer. We want our first term, a, to be 5. And there it is at the very end, E5. So we would bubble that in, and we'd move right along, and that's what we're going to do. We're going to move right along to question number 16 in the next video, and I hope to see you there. Thanks for watching.